So I'm not using slides for this part. I'm using the PDF directly. This is a special document. It's called Bob's Project Guidelines, Writing a Dissertation in Computer Science. So these are very detailed guidelines, and they have a special focus on the writing aspect of your dissertation. Right? So if you're not sure, for example, how do I write the abstract of my dissertation, this document will tell you the general strategy for writing an abstract. That's the idea, right? And look, this is kind of funny because there's an abstract. This is an abstract for the document, right? So that's an actual abstract. But then it also says how to write an abstract at the second paragraph. So the first paragraph is an abstract, and then the second paragraph is how to write an abstract, right? These detailed guidelines attempt to explain the mechanics of writing a third-year or master's project dissertation in computer science. They serve as a useful starting point for students and new advisors in their third or fourth year of study in the computer science department of a UK-based university. After all, no one is born knowing how to write a dissertation, yet there are many certain elements commonly that can be found in virtually all good dissertations. We give our recommendations as to each section a good dissertation consists of, as well as what each section contains. These guidelines are generic and can be customized to fit most projects. The guidelines are open and free to use at any university or institution without permission. So these guidelines have been published in a journal. I can't remember the name of the journal, but since they're published in a journal, that means they've gone through a refereeing process or a peer review process. So these guidelines have been submitted to the journal, and then some other external referees reviewed them and either approved them or, well, they didn't reject them because it got published, right? So it's been through a peer review process. That's what's special about these guidelines. So they're actually published in a journal, and that means you can cite them, right? And the journal information is here, right? The journal is called Innovation in Teaching and Learning and Information in Computer Science, or ITALICS. Right, volume 10, number 1, February 2011. And then it has a DOI. Does anybody know what a DOI is? Digital Object Identifier. Do you know what that's for? For published papers. Do you know why it exists or anything like that? Yeah, it's a unique ID assigned to every published paper, and it sort of indicates the authoritative version of the paper, since there can be multiple versions of a paper. There can be like the author's version, or a preprint version, or a version that has not finished the peer review process yet. It's like the final version of the document, and it's got a special identifier number, so that when we refer to the document, we're both looking at the same thing. You know, if two people are looking at a document and they want to be sure they have the same thing, the same versions, you can use the DOI to make sure you have the same version. Right, and you can click on the DOI, and then you can find the actual version. And look, it has 16,000 views. So this gets, you know, it gets views, gets downloads and views. Okay, so How would you write an abstract? We believe that writing can start with an abstract. However, in practice, writing usually starts with the background section. So that's the related work section. Usually your writing starts with the related work section, right? It can start with the abstract. The abstract can be 6 to 12 sentences. It's a difficult starting point, but it forces the author to write down a concise description of what it is they are researching and the associated benefits. Chances are, if the author can't write an abstract, then they don't really know what their own project is about. Of course, the abstract will be refined and updated over the lifetime of the project. The abstract can concisely identify the project topic, identify the benefits and advantages that the results, and if there is any novelty, describe the novelty of the presented work. If there's a description of the project in a previously existing project selection brochure, then that can be used as a basis for an abstract. You're choosing projects a lot from your project brochure, so you can start with that as an abstract. Does that make sense? So these are very detailed guidelines, right? 17 pages long. We're not going to go through every section in this much detail. These are for reference. We're just going to look at these briefly. Right, so they have a table of contents. Now this table of contents is a role model for how your own table of contents can look, right? If you're wondering how should my project be organized, this is how you can organize your dissertation, right? It has introduction and motivation. And look, there's a little comment here. The introduction and motivation is included in your initial document, the interim document, and the final dissertation. So that means all three documents have the introduction and motivation in them. But it gets updated each time. Now for one-year master's students, there's no interim document. That's only for the enhanced MSc students. So you'll have the initial document and then the final one. That's it. So there's information about formatting using LaTeX, project titles. Like if you're wondering what a good project title is, there's a background section, right? It consists of related work, previous systems or similar applications. If you're working with data, if you have a data-centric focus on your dissertation, you can put the characteristics of the data in that section. There's a little paragraph about citations right here. Then you have a project specification section, right, included in the initial document. You have a feature specification, and then a technology choices section, and so on. Project plan and timetable. The interim document is only interesting for extended enhanced MSc students. There's a project design section, an implementation section. These are all the subsections. A testing and evaluation section. Results, performance analysis, conclusions, future work, and then turning in source code. Right, acknowledgements. There's an appendix here. You might have appendix. You might have you'll have references. Right, and there's the introduction. So these guidelines tell you how to write your introduction. Because maybe you don't know how to write an introduction. There's a special format on how you can write an introduction, and it's described here. Right? When you write your introduction, the word introduction is not very helpful. The word you want to be thinking of is motivation. Like, why am I writing this and what is it good for? Like, that's the motivation behind your project. Right? So it says introduction, it's really about motivation, right? Introduce the topic, followed immediately with why this is a useful project, possible applications. What is this dissertation topic good for? Is really the question we're trying to answer in the introduction. And then there are some questions you can think about. Does the presented work provide a software tool of some sort? Right? It could. Does the presented system provide interactive features? Who will potentially benefit from this work? Does the tool or system provide new insight in some way? What does the reader potentially gain from reading the dissertation? These are all the kinds of questions that you want to think about for your introduction, right? And then it goes on, right? Words like contribute, benefit, advantageously, and possibly novel are used in this list, right? You can actually use a list. And then the introduction section concludes with how the rest of the dissertation is organized, right? Section 1 is this, section 2 is this, section 3 is that. There's some guidance on formatting. There's some guidance on LaTeX. There's even guidance on choosing a project title, how to choose a good project title. This is how to organize your background section. So your background section consists of the related work, right? The related research papers there. And then it also has previous systems or similar applications, right? Is there existing software out there that is similar or related to what you're working on? Probably there is. Probably there are some existing software applications, like on GitHub, for example, that have already looked at the problem you're working on. Right, and for each existing system, you provide the following information. You have data characteristics as well. Forgot to put my phone in airplane mode. If you're working with data, you describe the data here, right? There's a project specification. The project specification says what features are you going to work on if you're developing software, right? If you're running an experiment, then you would discuss the experiment here, like what experiment do I plan on running, and how is it going to be organized? What technology am I going to use? This is a challenging question for computer scientists because there's so many options. You have different programming languages, you have different software libraries, you have different hardware choices, different hardware libraries, and you have to make some choices, right? And so here you discuss those choices. I chose Python because it has very good natural language processing features, for example. And the advantages of this library over this library are the following, right? Those are the kinds of topics you discuss there. So you have different programming language options, different hardware, different operating systems, you know, all sorts of technology choices you have to make, right? Then there's a project plan and timetable, right? That's a sample, right? Every initial document has some sort of project plan and timetable. There's a sample timetable. There's a little bit of advice on time management. There's a little bit of advice on proofreading, right? Somebody other than yourself should proofread the document. There's a section on the interim document. This is only for the enhanced MSc students that need to have an interim document. How the interim document is organized. there's a section called project design. So how is your project organized? You need to organize it somehow, right? We know that software goes through an organizational process. Experiments are organized. Everything is organized somehow. This is an organization diagram right here. This is called a process diagram, right? And it's just an example of a process. There's different stages of a process and how one process follows another, right? So you have process diagrams in your project design section, or you could have process diagrams. Design diagrams, you can have system diagrams, class hierarchies, for example, if you're having software, right? Class diagrams. This is another example of an overview diagram of some software, right? How it's organized, what subsystems it has, and so on. There's some advice about using figures and images. Like all of your dissertations are going to have figures and images in them. Which ones are you going to have, right? That's a question. And then what are you going to use to make them? If you draw your own diagrams, how are you going to draw your own diagrams, for example? There's another example. This is a class hierarchy diagram. So if you have some software you're writing. And then implementation. Implementation has basic must-have features, and it also has enhancements or extensions. Right? You have to think about the features that are absolutely necessary in order to have just a basic implementation, and then you can think about enhancements and extensions, and so on. That's another example of a composition diagram, right? You generally comment your source code. You comment your source code using JavaDoc, for example, right? Your project follows coding conventions. You have a testing and evaluation strategy that you want to think about, right? You have a results section. You could look at performance. Maybe what you're doing is trying to make an existing process faster. In that case, you do a performance analysis. Not everybody will be doing that, but that's just an example. Conclusion section and a future work section. Any questions about that? So that's a lot of information. It would take a long time to go through all of this section by section, so I'm just giving a little overview and a little introduction. These are here, this is here for future reference. It's a reference guide. So you refer back to it during your dissertation. Right, when it comes time to write the related work section of your dissertation and you feel completely lost, you can say, oh, I'm just going to look at Bob's project guidelines and maybe that's going to help me write this section. Right? That's the idea. And those are some references, example references. Any questions about Bob's project guidelines? Is everybody really happy? They're like, oh, I'm so happy that these guidelines exist. Right? So whenever I'm feeling lost, I can look at these. Like, these guidelines didn't exist at one point. They just didn't exist at all. Like, for example, when I started working, these didn't exist. So I thought, how can the students do dissertations if they don't have guidelines? There should be guidelines, right? So I wrote, it took me a few years to write these. Not full time, but I worked on these and updated these over like 4 years, right? Section by section, thinking carefully, like what goes in each section, the structure. There is a section missing, by the way. That's a difficult question. If you know the answer to that question, then you're like a superstar, superhero. Anybody know what section is missing? That's a difficult question. There's one section that I didn't write about because I don't care about it. But it is a good section to have in your dissertation, and most academics will want to see it. It's my favorite or least favorite topic. It's called risk management, right? There's a risk management section that is not described here that most supervisors will want to see. But I'm not going to talk about it because it's not very interesting. Let's be honest. It's not that interesting, is it? Like, if I get sick, what am I going to do? I'll ask for an extension. It's just not that interesting. Any questions?
I have a question about programming language choosing. So when I choose a programming language, I might read some online blog. Is that a good resource for me to find that process?
Yep, you can read online blogs. You can just Google like advantages. You could just Google, for example, Python versus C and see what happens, because people will have written articles that compare, or advantages of Python versus Java. You could Google things like that and you'll find comparisons.
But I might need to reference those things. That's not a good source.
You can cite those articles. You can also find research papers on those topics as well. So you can go to Google Scholar and put in like Java versus Python and see what has been published on the topic. Yeah. Usually what I tell students is choose the technology that you're most confident with. If you have something you like, you think, I like Python, then just use that. If you like Java, then use Java. That's the advice I give to my own master's students. Because it's very difficult to learn a new language at the same time you're working on your project. Any other questions? That was a good question, by the way.
Would the document be content that the was section 7?
It depends on who's scoring the document. So that's something you want to ask your supervisor. I personally do not count the words. I'm probably supposed to, but actually I don't. When I'm looking at a dissertation, I want to see this information, basically. And I don't actually count the words. But some staff members might count the words. So ask your supervisor if they count the words. Any other questions? I mean, like I probably mentioned this last week or last time, I already have a good idea of how good the project is before I even look at the dissertation, because I'm meeting with the students regularly. We're following Bob's minutes of meeting protocol, so I can see what they've done each meeting, their progress, how it lines up with the to-do list, and they show me like what's going on each time we meet. So I already have a good idea, like, this is a good project, or this is not going as good as I hoped it would, or whatever, you know. Any other questions?
I saw some paper that is discuss section, but there is no discuss.
Oh, discussion section? Yeah, you could have a discussion section. That would be like the conclusions kind of. You could have a section called discussion, which is about the things that didn't go according to plan, for example, or I tried to do this, but this is what went wrong, and this is how it could be solved if there was more time, for example. You could also call it a section like limitations. That's another possibility. What's your name, by the way?
Wen Tao.
Wen Tao?
Yeah.
You're gonna do really well. You're gonna do well, I can see that. I don't even have to read your dissertation. Any other questions? I think there will be lots of questions. By the way, like, you can ask questions the whole semester, so don't panic. What's your name?
My name is Simon.
Simon.
Yeah, I have a question. So in the section, say, project plan timetable, do we require to have like a chart, Gantt chart, for example? Because I see some project need to have Gantt chart.
Yes, it's a good idea to have a Gantt chart, yeah. But don't sweat too much about it, because like none of these projects go according to the time plan. It's more of an academic exercise. And it's like that like in industry too. Like industry, you try to plan a software project, but it never goes exactly according to plan. And in reality, you don't really know what's coming. You don't know what you're going to do exactly, because you've never done a project like this before, probably. And you need like this sort of agile process. You need this iterative process where you have a meeting, you set some tasks, and then you try to work on those tasks and then reassess the progress of those tasks. So you need an iterative process throughout your project, and you just cannot predict that knowledge in advance. So there's a timeline there, and there's a sample timeline there about what you can put in there. You can Google like what goes in a good timeline. You can Google for a Gantt chart, but it's very academic and theoretical. So when I'm looking at it, I just look to see that it's there, that it has a logical structure, but that's it. I just look 60 seconds maximum at that section. Yeah. Other questions?